Hello, today I will discuss about my final project presentation, GIS-Based Spatial Analysis of Crime in Chicago, prepared. Introduction today. GIS-Based Spatial Analysis Crime. In this exploration, we have dived into the integrating world of crime pattern in the city, utilizing the power of GIS. Our goal is to not just understand our crime pattern, but to identify hotspots and reveal the link factor influencing this distribution of crime. Join us to this journey, like we are going to discuss more about it. So first, my research questions. Let's delve into the core questions that guided our research in 2023. How did overall crime rates evolve in Chicago, and what factor might explain these trends? Furthermore, where are the spatial spots for specific types of crime, and what are the unique characteristics of these hotspots area? Our analysis of crime rate throughout 2023 we identified different types of methods for that, how to use to solve these questions. So first we started here are some background information about these factors or these analyses that we did, factors such as economics condition, community programs, law, and external events like public health crisis or social. This understanding is critical for policymakers and urban planners. So now let's talk about the methods and tools that power data collection. Started with Chicago data portal, where we got the shape file and also the data we got from professor who also downloaded, like it is like from the Chicago portal. For analysis, we turned we use ArcGIS Pro, also special statistic tools such as spatial autocorrelation, optimized hotspot analysis or hotspots analysis, cluster and outlier analysis, kernel density and symbology. These tools serve as analytical detective. So we'll start with the spatial autocorrelation. Mapping can be tricky, especially when dealing with different datasets. To ensure accuracy and meaningful, so first we need to identify or define a projection, like the projection which is related to Chicago, like a coordinate system. And also, secondly, we need use spatial join tools to join the coordinate, the points of the crimes with the shape file or with the polygon with Chicago boundaries. So this where like spatial joins come in, allowing users to combine diverse data sets such as Chicago boundaries and crime incidents based on their spatial connection. This investigation provides a holistic view. Uh, a spatial autocorrelation we our spatial autocorrelation analysis method was instrumental in identifying clustering or dispersion patterns by examining whether crimes incidents show spatial clustering. We gained insight into regions with spatial dependence or high crime cluster. The result highlighted significant clustering of crime counts in specific area of the city, providing valuable information uh, law enforcement and policymakers, like important for policymakers. And so as we are seeing the report of the, so in the report we can see that so the analysis revealed the significant clustering of crime counts in specific area, like supported by positive Moran index. So you can see that it's positive or negative, and also high score D, like the Z value is very high and also very low P value. This indicate that crime are not randomly scattered but from cluster. And here we use like the output from the joint spatial joint. So we use that, and also the input field was also joint count, like as we counted in the joint spatial joint. And also the distance bands that generated, it was like 3,500. So for the optimized hotspots analysis, so going around simple hotspots analysis like emerged is like to identify statistical significant hotspots and cold spots. As you are seeing here, like the red area is hotspots where there is lots of crime incidents, and the blue area is cold spot. As you can see the so here, this method considers the spatial arrangement of features, allowing us to pinpoint areas where crimes is diverge significantly from the expected norm. The result is like more nuanced understanding of the intensity and distribution of crime hotspots, akin to uncovering the beating heart crime in the city. So here we also like use regular hotspot where you use fixed instance 2500. So and the result of this is also like the hotspots area have high crime, so high concentration of crime incidents, and cold spots is like lower. You're seeing in this map. Crime often exhibit spatial pattern forming cluster or outlier. Outlier. Our cluster and outlier analysis help us identify statistically significant cluster of high and low crime counts using the same distance band for uh, comparison. The map displayed census tract with significant differences in crime. So blue census, as we are seeing here, uh, it represents the area with low counts surrounded by high counts neighborhood, while red area here areas depicted high counts in areas surrounded by low counts. It's like finding the unique players in the crime landscape. I mean, so kernel density visualizing crime density is like creating a, like a weather map, but for crime in our kernel density estimation, we choose smaller cell size of 600 for detail and fine grain density surface, ensuring high accuracy with a search radius of 500 meters. We aim to balance a smooth and generalized surface with emphasizing individual point location. The result, a clear and accurate depiction of crime density patterns in Chicago represented in visually appealing heat map, as we are seeing in the map that the red areas have high density and the blue areas have low density. So in discussion now, let's also about engage in discussion about the factors that could affect our crime, analysis results, and explore potential future research direction issues such as data quality, reporting, uh, and limitation in our methods are critical consideration to enhance the reliability of our finding. So, the result I will say that mm, so several things could affect our crimes analysis result like problems with the data quality, how crimes are reported, and limitation in the method we use to make our finding more reliable. We need to check that data for my mistakes and uh, like how crimes are reported. Looking ahead, we should also improve our analysis method and consider how crimes pattern change over time and understand how things like jobs and education might be linked to crime. It would also be helpful to study of community programs and different policy strategies have a long lasting important impacts on reducing crimes. By looking into these things, we can get a better picture of what is really going on, what is crime in Chicago, and figure out better ways to keep communities safe. Thank you very much for listening to me and have a nice time.